Alright, so in this problem they're asking us to find the values for each pair. What they mean is for each pair of expressions in each part. So we're figuring out what each of these equal, and then they ask us to make a statement. What can you conclude about multiplication with negative numbers? So let's look at part A. We have 4 times negative 3 and negative 3 times 4. Well, we know that 4 times negative 3, I hope, can be thought of as 4 groups of negative 3. So negative 3 added 4 times, and that would give us negative 12. Well, in the next problem we have negative 3 times 4. And I'm wondering, does this mean that we could also think of this as 4 times negative 3? Can we move the numbers around, like use the commutative property, just as we can with positive numbers? And I'll test it out on this one to reason through on the number line. In the first case, we can say, okay, let's start at 0. If I have 4 groups of negative 3, I hop down by negative 3 each time I'm adding a negative 3. So I have 0, right? And I'm hopping 4 negative 3s. Negative 3, negative 3, negative 3, negative 3. And that brings us down to negative 12, and that's this one right here. In this one, we have negative 3 4 times, right? So actually, that's the same thing. Starting here, negative 3, negative 3, negative 3, negative 3. So these are going to be equal. And this is giving me the hint that in each of these cases, multiplication is commutative, and that we can move those numbers around in any way that helps us. So in the next one, this dot right here, well, that means multiply. 2 times negative 4, think of 2 times 4, that's 8, except now we're dealing with a negative value. Negative 4 times 2, think of that, again, as 4 times 2, it's also negative 8. Now again, here with these parentheses, they're just trying to highlight the negative number. They're not trying to confuse us in any way. But both of these, we think of 2 times 3 as 6, and they're both positive 6, because a negative times a negative is a positive, which fits a pattern that we established and discussed in other videos. Last, we have the fraction. This is 1/5 times 4/9. My approach here is more procedural than intuitive. I use a standard algorithm where I multiply everything right across. Except the main confusion is, what do you do with this negative sign? Well, the interesting thing is, and we might get to this in other videos, is that you can put it anywhere. You can associate it with the 4 or the 9. In the end, we get the same answer. So let's put it with the 4 on the numerator. I like to do that. Keeps it simple for me. And now we have 1 times negative 4, and then 5 times a positive 9, right? We apply the negative value to the negative 4. And this time we get negative 4 over 45. And I know I'm going to get the same thing here because what I'm realizing in each of these is that multiplication is commutative. You could always change the order and not change the answer. Alright, hope that helps.